Alright, on this position versus time graph, we're going to translate it into a velocity versus time graph. So the first thing I need to do for my position versus time is take the slope of each segment. So I'm going to put some dots on my graph so I know where I start and I end for each segment. And now I can begin for my slopes. So A, when I look at rise of A, I have a rise of 10 meters. My run of A is 2 seconds. So for A, I have a slope of 5 meters per second. For B, it's a flat line, so I have a slope of 0 meters per second. And for C, my slope is going down, so my rise is negative. I have a rise of negative 10 divided by, this is over the course of 5 seconds, so from 5 to 10. So I have a speed or a velocity here of negative 2 meters per second. Alright, get rid of that because it looks kind of like an equal sign. So now for my velocity versus time graph, I have some positive velocities and some negative velocities. So I'm going to put my 0 in the center here. My time needs to match, so 0, 2, 4, 6, 8, 10. My two graph times need to match. It's showing the same velocity, or I'm sorry, the same motion or the same period of time. Now when I count up, I'm going to go by 2. So negative 2, negative 4, and we'll go 2 and 4 and 6. Alright, so now for this graph. For segment A, I'm going to put it in blue. So segment A, I'm traveling at 5 meters a second for the first 2 seconds. So I'm going to find 5 at 0 time. I'm traveling at 5 meters per second. And then 2 seconds later, I'm traveling at the exact same velocity, giving me a flat line here. So this is segment A. For B, I'm traveling at 0 speed, and I do that for 3 seconds. So from 2 all the way to 5, I have 0 speed, or velocity, I'm sorry. And I'll connect that with a dotted line. Last but not least, for the last 5 seconds, I'm traveling at a velocity of negative 2 meters per second. So from 5 to 10, I have a flat line at negative 2. That's your translation of position versus time into velocity versus time for this graph.